Mean value theorem says that if there is a function and it is continuous on a closed interval ab, and if that same function is also differentiable on the open interval ab, then there is a number c in ab such that the derivative of c is equal to the average rate of change between a and b. So this is really the same thing as Rolle's theorem, but it's just tilted sideways. So if I were to think of Rolle's theorem, where a and b were right next to each other on the graph, then it's much easier to tell that at some point that there must be a derivative of 0. But if I were just to use my tools to tilt the graph of this axis to make it parallel with the x-axis, then Rolle's theorem would apply. So I think that, firstly, is the easiest way to think of it, because there really isn't any difference. I can still have the same situations. If there is a straight line between a and b, then the derivative will be equal to the average rate of change. If I remember, this is the average rate of change. The derivative is the instantaneous rate of change. So what this is saying is that at some point between a and b, if these 2 points are connected somehow, then at some point there will be at least one place where the instantaneous rate of change will be equal to the average rate of change. So on this graph it'll probably occur somewhere around here, and here it'll probably occur here and here. The easiest way I can think of to describe this theorem is to think of driving. Suppose I were to drive from where I am right now to the other side of the country, and let's say that my average speed was 65 miles an hour. It would probably be faster than that, but let's just say it was 65 miles an hour. What this theorem says is that at some point in that trip, at some point in that trip where I averaged, I'm here, and I go to the other side of the country, 65 miles an hour, at some point I was heading at the velocity of 65 miles an hour. I had to have been. I might have been going 30 miles an hour for quite a few hours and then increased to 80 miles an hour. But at some point in between this jump, I was going 65 miles an hour. So that is what this mean value theorem is saying. At some point, the derivative was equal to my average velocity. And if I think about it when I'm traveling, it just makes sense. In order for my average to be 65 miles an hour, that means I must have A, been going 65 miles an hour the whole time, or B, been going faster than 65 miles an hour. Say I rocketed out of my garage at 200 miles an hour, then at some point I must have slowed down and passed 65 miles an hour to go like 10 or something like that in order for it to average 65. And similarly, if I started out going at 10, obviously I had to have passed 65 miles an hour and gone faster in order to average 65 miles an hour. So that's the mean value theorem for you.